Let us begin with the concept of angular momentum. After studying a moment of inertia and torque in detail, is another key concept of rotation. And when you relate them, torque, moment of inertia, and angular momentum, this completes our knowledge about this rotation. So let us start with simple things, and then we will see mathematics behind angular moment, how it is made, how a direction, yes, is given for angular. It's just like a torque, direction just like a torque. आपण ते सगळं बघूयात. बघा, समजा आपण एक पार्टिकलचा विचार करू. सगळ्यात पहिले आपण एक टर्म आठवूयात जे आपल्याला ऑलरेडी माहिती आहे. माय सजेशन्स टू स्टुडंट्स इज देअर. Always compare rotational motion with its analogous quantity in a linear motion. So it will give a better. So let us begin with a linear moment. So we have studied this. बघा, linear momentum म्हणजे काय होतं? What is mean by a linear momentum? So suppose this is a particle. This particle has some mass, and yes, this has suppose velocity v moving in this direction. Then linear momentum notation is just mass into velocity. Mass into velocity. So that gives a linear momentum. But see, this particle is having a linear motion here. So this is moving along straight line. Then linear momentum become mass into significance of, we have studied significance of this quantity. This is nothing but movement of the mass. Mass is not at rest. When mass is moving, that particular stop nothing but a linear motion. So we know this is directly proportional to mass and also directly proportional to. बघा, एखादी बुलेट आहे, खूप मोठ्या खूप हाय वेलॉसिटीने ती ट्रॅव्हल करत असेल. इट हॅज लिटिल मॅस. ओके, इट इज इन सम इन मे बी इन ग्राम्स, बट स्टील इट इज हार्ड टू स्टॉप. त्याचा मास खूप लहान असून पण इज व्हेरी हार्ड टू स्टॉप बिकॉज ऑफ इट्स वेलॉसिटी. म्हणजे त्या मासला त्या वेलॉसिटीमुळे काय ते एक स्ट्रेंथ येते असं म्हणता येईल. दॅट इज नथिंग बट अ मोमेंटम. अँड इन अदर केस समजा एखादी ट्रक आहे आणि खूप अशी स्लो जातं, तरी आपण त्याला स्टॉप करू शकत नाही. वेलॉसिटी खूप कमी आहे, व्हेरी लेस. सपोज इवन दो इट इज 1 किलोमीटर पर आवर, बट वी कांट स्टॉप बिकॉज ऑफ इट्स अ हेवी. सो मास अँड वेलॉसिटी both equally responsible for linear moment. So this was a linear momentum. ठीक आहे, this is our not purpose to study a linear momentum. But see, या लिनियर मोमेंटम पासून आपण अँग्युलर मोमेंटमकडे जाऊया. बघा, एखादा पार्टिकल आहे, अगदी सोपं आपण बघूयात, नंतर माझ्या कन्सेप्टला जाऊ. समजा हा पार्टिकल आहे. ओके, दिस इज अ पार्टिकल अँड दिस ॲज अ मोमेंटम. ओके, दिस ॲज अ मोमेंटम m into v. And if suppose any point is given, any point is given here about which is rotation possible, then see what happens. This is a perpendicular. Suppose this is perpendicular distance, any distance. बघा, ह्या पार्टिकलला आपण काय करू, सर्क्युलर मोशनमध्ये समजा घेऊ. आपण सर्क्युलर मोशनमध्ये जरी घेतलं, सपोज दिस इज अ yes position at any point. Suppose this is moving in this way. This particle has this much of linear. बघा, याच्यात सगळ्यात महत्त्वाची गोष्ट लक्षात ठेवा, जरी पार्टिकल लिनियर मोमेंटममध्ये असेल, जरी पार्टिकल लिनियर मोशनमध्ये असेल, इट कॅन प्रोड्यूस अँग्युलर मोमेंट. दिस इज अ ब्युटी ऑफ फिजिक्स. कॅन प्रोड्यूस, यस, अँग्युलर मोमेंटम. हाऊ इट इज. तर काय करायचं आहे, समजा हा पॉईंट ओ आहे. सो दिस पॉईंट इज ओके. So this linear momentum mv into this particular distance r. So this product mv into r is simply angular, the simply angular moment. Angular moment म्हणजे काय म्हणता येईल, बघा, आपण दुसऱ्या भाषेत मोमेंट ऑफ फोर्स आपण शिकला, फोर्स इंटू डिस्टन्स. इन मोमेंट ऑफ इनर्शिया वी हॅव स्टडीड मोमेंट ऑफ मास also. The moment of inertia is the second moment of mass. Mass into distance into distance. So similarly, remember first note of this angular momentum is angular momentum. Remember, angular momentum is moment of moment of linear moment, moment of linear moment. हा linear momentumचा moment आहे. That is angular momentum. So what is this angular momentum? Let us take nothing but what momentum into distance. So L is equal to always L indicates angular momentum. L indicates angular, and this P indicates linear momentum. And this is the perpendicular distance between yes direction of P. बघा आता आपण थोडेसे सर्क्युलर मोशन मध्ये येऊयात. इथे बघा समजा हे पार्टिकल इज मुव्हिंग विथ सम वेलॉसिटी moving around circular path, and this is its yes you can say this is the axis of rotation here. Then how to calculate angular momentum in this, as is a angular motion, particle doing angular motion. So इथून एक वेक्टर आपला काढावा लागेल जो याला परपेंडिकुलर असेल, that is the r. And what is the direction of linear momentum? So we know that linear momentum has same direction of as a velocity, same direction as well. So angular momentum of particle about any point O, about any point O is remember it is a moment of its linear momentum. Moment of its linear momentum means again same story, mv into mv into. So we can write this is a momentum, angular momentum, and this is mv into s. Mathematically, आपण बघूयात पुढे. Mathematically, remember this is you take this as a momentum, angular momentum, which is yes cross product of cross product of linear momentum and its distance from given. Just similar, torque is a cross product of force and distance from given axis of rotation. That is nothing but angular momentum. बघा एखादा पार्टिकलचा अँग्युलर मोमेंट मला कळलं आपल्याला की हा काय इट इज अ मोमेंट ऑफ, रिमेंबर इट इज अ मोमेंट ऑफ लिनियर मोमेंटम. बघा जॉमेट्रिकली याला थोडंसं आपण अजून एक्सप्लोर करूयात. समजा बघा इथे आपण काय कन्सिडर करू, वाय ॲक्सिस अँड सपोज एक्स इज एक्स ॲक्सिस अँड सपोज दिस इज एनी पार्टिकल इज सिच्युएटेड ॲट सम पॉईंट. आपण काय करतो मग आपण पोझिशन वेक्टर. ओके, so this is a position vector. Say yes, the position vector say any distance. And suppose it has velocity. This particle has suppose this velocity v. Then we have to do one thing. What? We have to extend this line of action of velocity. And this point is O. And if you take, if you manage perpendicular distance between them, say this is okay. Then yes, then what happens? So this is again a direction of mv. So angular momentum about O is always equal to mv into this particular distance O. Okay, this is a proper showing of this angular moment. बघा एखाद्या पार्टिकलचा एखादा पार्टिकल लिनियर मोमेंटम लिनियर मोशनमध्ये जरी असला तरी आपण त्या एका पर्टिक्युलर पॉईंटमध्ये त्याचा अँग्युलर मोमेंटम काढू शकतो इफ यू नो perpendicular distance between the line of action of momentum and given. And if particle moving along circular path, it is so obvious we can calculate angular momentum. So for that purpose, we need a momentum, linear momentum. I am calling just momentum is nothing but linear momentum. So linear momentum into distance. Mathematically, it is a cross product of cross product of distance and its. Okay, we have seen for a particle moving along straight line, we can calculate angular momentum. Okay. If particle moving along circular path, even though we can calculate angular momentum, but what about a rigid? What about a rigid body? बघा आता रिजिड बॉडी मध्ये जर आलो आपण, रिजिड बॉडी इज दिस. We have studied what is a rigid body in first lectures. So rigid body, and suppose this is the axis of, suppose this is the axis of having some angular velocity, and this is the point O, which is from which passing. So angular momentum, by usual definition, angular momentum is what? Is a measure of the quantity of rotational motion in a body. The angular momentum of system of particle is what? Yes, it is a sum of angular moment of all the particles forming the system. A rigid body is an, it is an assembly of, then collection of, the combination of number of parts, maintaining their mutual distances under all circumstances. So what happens here? Suppose we have considered different particles. Say this is one particle having this m1 and distance is this distance is. So similarly, we can consider number of particles for rigid.